In this video, I'm going to show you how to generate a distribution or a histogram if you have a fluctuating data. For example, in this file, I have a time series of end-to-end distribution. That means the first column is time, and the second column is the distance between the first and the last beats of a polymer. The units are in nanometer and the time units are in picosecond. But this is just for an example. This data file could also correspond to the age of several persons in a city or in a country, or even in a class, the marks of all the students. So the nature of the data doesn't matter. And this example specifically shows you that how to create the distribution using XMGS. So let's first open the file in XMGS. And as you can see, let's just do some rescaling. Okay, so it's starting from 0 and ending in 1 into 10 to the power 5 picoseconds. And the y-axis is the end-to-end distance. So the protein or the polymer started with end-to-end distance close to 8 nanometer, and then it sometime decreases, increases, decreases further, and then increases and comes close to 4. So now if you want to generate a histogram or distribution, it's very easy to do in XMGRACE, and sometimes it's more convenient um, in contrary to showing only the fluctuation data. The fluctuation data with time can be important when you are studying some dynamical process, when you are interested in the kinetics of the system, that how long does it take for the polymer to decrease the end-to-end distance and come close to each other. So the end-to-end distance close to 0 means the two ends of the polymer are very close to each other and the polymer is forming a loop kind of conformation. So anyway, but if you are not interested in the kinetics and you are interested in the ensemble average of the structure, then plotting a distribution is much helpful and it's a better way to represent. So you have to go to data, then go to transformation, and there is an option called histogram. So go to that, click on the set, make sure to click on normalize, otherwise it's difficult to compare histograms obtained for different proteins, different systems. And then here you have to put a value that is the lower limit of the system. That means there is no value that is below this one. So in this case, it's 0. The end-to-end distance cannot be less than 0. And the highest value could be, say, 9, because I cannot see any value in this data file above 9. And this is the number of bins. That means how many bins you want in your histogram. And here, as an example, I take, say, 45 bins, but you can take anything according to your preference, and then click on apply. As soon as you do that, you can see another data set is created, but the scales of these two plots are so different that you cannot see them in the same graph with the same scaling. So you right click on the first one, hold the right click and click on hide. So the first set is now hidden, and then come here and click on auto scale. If you do that, let's close this, and you can see the histogram. So the histogram tells you that the most probable value of the data is close to 6, and it spans over, say, from 0.5 to 8.5. And if you don't like this representation, you can always change that and go to the second set, and then instead of left stairs, click on straight line, and click on apply, and then go to line, click on draw drop lines. It is turned on, so make sure to turn it off, and you can get a cleaner histogram. Now, if you want to change the number of bins and make it even smoother, you can still do that. So this is still is your source, and you change the number of bins to 90. Click on apply, and you can see the bins are now narrower. And you can even decrease it, say make it 20. So your bins are now wider. And in this way, you can find the best way to represent your data. That's all for this video, and thanks for watching it.